So it is my honor and privilege to welcome our second presenter, Kassim Muitondi. Kassim obtained his PhD in statistical data mining from the School of Mathematics of the University of Leeds in 2003. He's a well-rounded, multidisciplinary professional. He also holds MSc degrees in statistics, computing, and in finance. Kassim has taught a wide range of courses: applied statistics, computing mathematics, research methods, data mining, business intelligence, data science, and many more. He has supervised undergraduates and postgraduate dissertations, as well as several PhD theses to completion. His teaching, research, and consulting home in on real-life data-driven solutions using data science tools and techniques for structured and unstructured data modeling. He has established strong academic industry partnership via apprenticeship and industrial placements, and he provides training and consultancy services for practitioners on various aspects of project management. It will take me the whole day reading our speakers' bios. Because of time, I'll let Kassim speak to us. He will share his experience and his knowledge in what he has done. Kassim, the floor is yours.
Yeah, so I will have to ask my colleague Simon to do the live demo because he's, I would say he was online.
Yeah, Kassim, can you hear me that side?
Technical guys, you can assist us in loading the presentation, please.
Right, okay, thank you very much. Glad to be here. This is a joint work between me and our industry partner, Simon, who, as I said, Simon can hear me. He will do part of the presentation and do the live demo via Zoom. Right, so I'm going to be talking to you about a data-driven prototype for animal grading. This is a tool that we've developed working together over the last few years, and we're still work in progress. So the outline is we're going to look at the background and a bit of motivation. We look at the problem space, the aim and research question for this research project. We look at general and specific objectives, and we look at related work, and then we look at the methods, data acquisition and the implementation strategy, and then the deliverable, the animal grading system, showing the sort of data generation capabilities, which I will ask Simon to demonstrate in the next few slides. The main idea of all this comes from the notion of sustainable development goals, where we know 17 of them, and they span across the entire human spectrum. So we got SDG number 1, number 2, talking about poverty and hunger and food security and things like that. So the main idea of this project is to try and help small-scale and medium-scale animal farmers through enhancing the productivity in the work they do. So we'll be presenting to you a prototype of a tool that helps these animal farmers improve their productivity. So as I said, the motivation is all about sustainable development goals and coping with the advances in computing power and the data extraction. We know that now we can do an awful lot of things. If our previous work involves, a few citations there. You can get those online. They're open source available. We published them in the last few years, and some of that work has actually previously been presented here in South Africa. Right, so the problem is that in many countries, especially in the developing world, we have a shortage of resources in veterinary services. So animal products are quite fragmented and disconnected. The overall investment in farming and the innovation needs enhancement to help with the productivity. So we are aiming to capture useful data on animals' body condition score at the farm level, and for which we'll be setting a research question. How can we apply machine learning techniques to remotely apply these techniques to help with the productivity among these farmers? We know that the answer lies in an integrated animal grading system and the cloud computing. This is something we've investigated. So in the meantime, I'm going to ask Simon to talk to you in the next 6 or 7 slides and probably do a bit of live demonstration of the tool, which I was going to demonstrate from my laptop, which cannot be connected now. So you can't hear him now, I just proceed with that. So unfortunately, you're not going to see the tool. I will be talking you through it. I thought this was probably the most interesting thing because you're going to see how the tool works, how we extract data from animals and different species, structured, semi-structured, and unstructured data. But I'm going to have to go through this actually by. So we know that small scale farmers face problems in animal health, animal feed, with financing, and also with the markets. In terms of health, we have statistics which show that livestock animals, 60,000 to 120 in East Africa versus 1,800 in Europe. These are basic statistics which reflect the challenges that farmers face in the developing world in terms of finance, health, feed, and markets. Now, in short, just to save time with that, all these 4 attributes here constitute a vast amount of data source. And I want you to keep that in the back of your mind because the health of our animals, if you go to the Horn of Africa today, you look at the farmers in Somaliland and Somalia and look at the animals and then compare to animals on a ranch in South Africa, you see the difference. So location of where the farmers are. Okay, as I said, in terms of finance, farmers only receive prices for livestock from traders in their villages. There's limited awareness of how they can grade and estimate these prices. So identifying and capturing relevant data attributes for accurate estimation of the value of an animal before they go to the market is crucial. And this can significantly enhance the productivity of the farmers. So for abattoirs, for instance, we've got a mix of lean meat versus fat. This is important. And here we've got an example where we've got a fatty cut against the lean cuts, which leads to different types of meat there, untrimmed, semi-trimmed, and lean trimmed, which you've got different values for that. Right at the bottom, you've got the marbling with the meat, which is a desirable characteristic, and it makes meat tender when cooked, but also very expensive. Now, if you sell low quality meat, high quality meat, there's a difference in terms of what you earn. Now, these are the sort of live demonstrations I was going to do. That's a scaler. Here we've got examples of a cattle, a pig, and a goat. You can see in the middle, let's see if I can get it right. In the middle, we've got 3 different types of thick animal, a moderate, and a thin one. The same technology is applied. This is a scaler. It's a slider ranging from 2 to 5, and that does help generate data for the quality of an animal.
Kassim, I'm back, just in case you're able to hear me now.
Farmers, the current project is actually run in India. The farmers are trained on how to assess the value, the amount of fat and the meat on an animal. You can see At the bottom, by feeling using your hand, or by touching or squeezing, you can get an insight into how much fat or how much meat there is on that animal. So estimation requires grading, and this is the tool that actually was developed. These values across the fatty class, you've got 5 classes, and down vertically, you've got the European standards. Is data generated, and the tool can actually be applied by entering these baseline values and providing estimates for different animals. So as I said, we developed this tool to allow workers to compare images, not only images, but also data that comes from the animals through estimation. So we set a number of objectives, which basically to train the farmers to collect the data, structured and unstructured, and to carry out machine learning. So of course we know, those who do machine learning know that carrying out machine learning starts from very basics of data preparation to model refining and predictive modeling. The ultimate goal for us is to ensure that we meet some of the sustainable development goals. There's related work which has been done previously. There are examples here I've given with citations, which I wouldn't like to dwell much on. We know that conventional methods, for instance, calculating the weight of an animal is a function of the girth and the body length. Again, this is one of the other things I was going to demonstrate live from my laptop, and I've been able to connect. So once we capture the key predictors, we are able to apply the modeling techniques.
Well, thanks for doing my session. I restarted my computer this side, so I missed that, but at least you're hearing me now. Let me just see if I can share my screen and see if that works.
Oh, that would be great if you can, Simon.
Are you seeing that now?
Yes, yeah, excellent.
Okay, great. So, hold on. So, any particular screens you want me to run through, or I'll just click through a few of these slides? So,
no, and if you can just show different breeds now, that means different types of species of goats in India. Now, of
sure,
course,
we have different characteristics. We have some focused on meat production, some meat and milk, and some meat fiber, as well as milk only. So, and then we have some of the local varieties as well. So we can select the breeds there. We can also enter information on the weight, and in case we don't have a weighing scale, we also have a method for entering the size of. Oh, that's too big an animal. But entering the size of an animal.
Just about twice that much. Yeah.
Yeah. So if I were to go to the photos, it won't work on the emulator, but we have outlines for specific views that we want to get of the animals, and we also capture the angle that the camera has taken the photo at to help with doing the grading later. If I look at the grading tool, the way this works is we have a slider, and here you're seeing some drawn images, if you like. We also have some real images of the animals, and we haven't got those in the changeover here. But we also have outline traces. So if I click here, we can also overlay the trace on the animal. And that does require that we resize the photo to make it work effectively. And what you're seeing here as well is we have a horizontal view of the animal. We have a slightly from the top view of the animal at the bottom. And the idea, you see a number at the top. This is actually the grade, the 1 through 5 Kassim was talking. And the usual convention is to have a 3, a 3 plus, and a 3 minus, and then go the other way. But we obviously convert
in the
these
interest
into
of time,
hard
Simon,
metrics.
if you can just go to the dung, the video of the dung, if you go back,
Hold on. let me just move this out of the way because it's just obscuring what I'm trying to do there. Okay, so I think. Hold on. Yeah. Okay. So let me just skip through here. So there are a bunch of production characteristics and reproductive characteristics for the animals that we look at as well. So sometimes we're grading only for meat. Sometimes we're grading for the reproductive value. And if I look at the health here, so we have some choices on dung, but these are actually then explained through some video animations, which can help farmers understand the quality of or the health characteristics that we're trying to assess here. And in some of the more
just to chip in that type of image can be captured in using convolutional neural networks. We can identify the type of health of an animal just looking at the dung. So that will help us identify the health condition of the color based on the color of the dung, and then we can use CNN to predict the current condition, health of that animal. Carry on, Simon, if you can.
Sure. And I'll just expand on health for 1 second, because we have a very detailed veterinary health tool that actually uses similar animations to explain symptoms and captures that. And another side, like Kassim says, is taking photos and imagery and using the neural networks to do the analysis there. So we've got information on the weight. Now this is important for understanding the productivity of the animals, and you can't easily capture that data, especially from smallholder systems, unless you can get a weight at 3 months. And sometimes you can get that measured. And that obviously gives you an idea of how much growth you get in that 3-month period. And I'll just carry on. And for the kids, we're looking at, collectively how many of them reach over 10 kg. So again, gives us an idea of the reproductive value and the growth of the animals. Anything else you want to have a look at?
No, I think that's just about fine. Simon, let me finish with the last 2 slides and then we'll be done. Thank you. Thank you, Simon, for explaining all this. So the requirements of this project, that we know that we want to convert data into information, into knowledge, into some services, improve services and products. So, but we know the challenges that we face. Those work in machine learning know that we estimate data, we validate our models using the data. All these are random, and the data randomness is an issue, and that's why we develop this machine learning methodology to capture the images, structured and unstructured data into this. I wouldn't want to waste a lot of your time for that, but basically that we capture the data, we clean the data, pass that onto the cloud, we process, and then we carry on refining the models and the results as shown in this strategy. So we developed previously on the right-hand side, we have an algorithm which was developed for parametric modeling. This on the right-hand side, but on the left-hand side is one which is integrated for parametric and non-parametric modeling, and this is what is applied to the slide which we showed you a while ago. And I think we've gone over time now. I'll have to end here. And any questions?
Thank you. A round of applause to Kassim and Simon. I know that at times technology dictates what we can and what we cannot do, but we have to adjust and do things accordingly. But thank you so much for sharing with us on animal grading system, and also the demonstration that Simon has shown us. This is just a token of appreciation from us to say thank you for participating in our presentation. Thank you so much. A round of applause for Kassim and Simon.